All right, we're recording right now.
Okay, good evening, everyone. So we are going to have this session as promised in the beginning of the course, and it's going to be mostly like a help session, focusing in things related practically to the assignment to using the machine learning library, the Spark machine learning library. That is the main point of the session. As an introduction to this, can you move the slide, Elena, because I don't have control on that. So the agenda has several detailed bullet point what we are going to do. In the beginning, what I'm going to do is wrap up what we are doing in the big picture so we don't lose track what we are doing. And then Elena is going to talk regarding the specific, very important key point when you use the Spark machine learning library. Next slide. So where we are in the middle of the course of big data analytics. We started defining big data, and we said that as a data analytics in big data, we are going to focus how to actually analyze, visualize, and search big data. But without proper storage and sharing, you understand that we cannot do that. So everything is quite related. That's why we are having a lot of reading in the classroom. We are having a lot of resources. And after reading all this, we are narrowing in something specific to do as an assignment. Why I'm pointing to this? Because I don't want that people lose the big picture. We are still in big data with hundreds of different product and technology. Is like a zoo park. How many names you can take there? Of course, you understand that practically we can read about them, learn about some of them, and practice about a small group of them. When we practice about small group of them, don't think that we are ignoring all other. We are doing this from practical perspective, and the course is delivered. We are taking, let's say, the most significant product in this subject we are talking about. So you practice in something which is, let's say, the most widely used product. That doesn't mean everything has to be this way. So next slide. Not this. No, you skip one. Or they are not ordered. Go next. I see, no, 6. No, 6. 6. Number 6. Next one. I don't know how they changed it, but we started here and then we went to Spark. So the course started with Hadoop Mapreduce, if you remember, right? That was the subject of the first 2 weeks of the class. And we studied the Hadoop ecosystem, which started with 2 main components: the Hadoop distributed file system, which is the storage part, and the computational part, which is Mapreduce. Beside that, we of course pointed to the number of different components in the ecosystem, which were developed all the way historically over the year to facilitate the work of the data analyst, data scientist, and the developer. Of course, even though we read and we study some of them, we were not able to practice with each and every one. So that is the big picture. And we selected to practice with the columnar database HBase. I want to point out here, what you did is a practical assignment. 1 on HBase is just a selection of what we overview on week 1 and 2. We went in some detail to some of these components, and we practically practice in what is HBase. And that is what we are following in this big data technology in each and every week, in each and every module. Next, we moved, next slide. Yelena, next slide. Next, we move to Spark, which is next level of technology of big data, which overcomes some restriction which Hadoop has. It works mostly on batch processes, but when we want to do streaming or different requiring more, let's say in parallel real-time processing of big data, Hadoop is not suitable. So the developer evolved with a new, again, open source product, which is Spark, which has a lot of advantages compared with Hadoop in sense to work with stream data. Again, we were talking about open source product and possibility to run in different fashion. Three of these different configurations are presented here. So in the beginning, we started with what is on top of the version 1, on top of Hadoop distributed file system as a storage of the data, Mapreduce and Spark. Then another version evolved, and actually the one which established it very well, the true one of Spark, is the one we have here, which is Spark standalone using Hadoop distributed file system or without Hadoop distributed file system, another storage, and the Spark engine. So the most important in Spark is in the next slide, which present the most important Spark component, which are the machine learning library, let's put it this way, the Spark streaming capability, the Spark SQL, and the graph. Of course, there is much more because over the years, Spark as a product of the open source community had this beauty open source. Many people work and contribute to have the more powerful product with different components which make the life of analysts, scientists, and developer easier and more efficient. So the main component we are going to practice is the package of machine learning and the Spark SQL. As you understand, as pointed regarding the first 2 weeks, here happened the same. We are talking about complex technology with extensive number of components, each one serving different purposes, and we selected the most important, which has to be at hand of the data scientist, data analyst to practice and to get practical knowledge. That's why we selected the machine learning library and the Spark SQL for your big assignment number 2. Next. So what I wanted to say up to here is don't get lost in the big picture. Look to the big picture, what we are doing. I mean lost because you can get lost and think only about Spark machine learning and HBase. But they are much more. We're talking about big picture, many different products, and we are practicing just with a selected one for practical purposes in a setting of a classroom. So very important when we talk about all these new technology students that we are learning new skills, and you understand that all this hard time you are having in the course is because you are learning new skills. These are the skills in addition to the data scientist. You are learning some data engineering skills, how to work in the cloud environment with big data, open source product like Hadoop and Spark. So this is very important that you keep in mind. These are new skills enhancing what you studied. You studied machine learning algorithm, build predictive modeling using Python in your desktop and RStudio, and now we are moving to different technology, moving all this knowledge to apply to solve problems related with big data. And of course, mandatory, all these things working in the cloud. Why I'm saying mandatory? The industry mandate this. Today, all the jobs of data scientists and analysts require, in some fashion, you are going to work in the cloud. Why? Because everyone, every company, small or big, their information technology infrastructure to the cloud. Why? Because it's more convenient for many different reasons. It's less expensive. And why it's less expensive? Because somebody else is managing for you. You don't need to have people who are going to manage this. You don't need to dedicate resources to pay license. You just have your services managed by a cloud provider, which is much more efficient, and you dedicate as a company in what is your big expertise. If your expertise is in finance, you dedicate your time in finance, and somebody else is managing all these cloud resources for you with the data and getting analytics for this data. So the benefits of cloud are very clear. And I want to tell you that you are learning a lot of new stuff, That's why, and this is in parallel what you are learning as a data scientist and analyst part. Working in the cloud itself is portion of learning. You are learning this in parallel. And very important, I want to point out that you have to understand that working in the cloud is not the same like working in your personal computer. Why? Because the cloud is less expensive because we are sharing resources. When you go and use services in the cloud, these are actually shared resources. That's why it's less expensive. This is not just magic bar, it's less expensive because are shared. And as a share, we have to learn how to use shared resources. And this is not just because we are in the education and working with educational account. This is just because this is the rule of working in the cloud. When your company deploy the services in the cloud, the same rule apply. This is not just like you have 98 degrees outside, warm, you have the air conditioning open, running, and you open all the door and window. That is not the way to do it, right? The same with the cloud. If you are not working, just stop the service, log out. Closing the browser doesn't stop the process running in the cloud. So you have to learn all these things, and not just because of the educational environment, because this is the way to work in the cloud, and this is the way you will be working in your workplace. So actually, that's are the main point I wanted to make before Elena gives you some practical advice regarding some very detailed key point to work and don't get frustrated with the use of the machine learning library. Elena, this is yours.
Oh, yeah. Well, I got frustrated with some people who put the credit card number in, so I put this slide. Okay, do not enter your credit card number. Maybe you guys gonna enter your social security next or something. No, I mean, I say it so many times. Still, at least 2 or 3 people entered the credit card number this semester. I'm not gonna say now who those people are. I'm gonna keep it confidential, but 2 people entered credit card number, 2 or 3. Okay, please don't do this. I'm not sure how else to tell this. Okay, now there are other important rules, which Yelena just said, to stop the runtime environment before you exit, or it will continue consuming your capacity hours. And then you're going to be tempted to do what I said not to do on slide number 8, right? Because you think that, oh, I'm going to put my credit card number, it's going to give me more hours. No, it's not going to give you more hours. Okay, so that's not the solution. No, you have to stop the kernel before you exit the notebook. And please do not contact IBM because they don't know your assignment. Okay. Now, when you submit the ticket, when I help you, you need to always respond to me, because what's going to happen is that if you don't respond, I'm going to send you a reminder and I'm going to tell your instructors that you're not responding. Okay. And then the ticket will be closed. I have to follow the rules. Okay. And so do you. Now here, this is just important. You have to upload data. You have to upload data to the project before you start working with a notebook. Do not delete object storage. Object storage is remember, it's a project area where the data is saved. The data, notebooks, everything is saved in object storage, right? Please do not open two notebooks in the edit mode at the same time, because you're gonna be running the environment twice. When you run the notebook, you have to start running the notebook cell starting from the top, okay? Or if you're done halfway through the notebook and you took a break, right? If you take a break, you stop the kernel. And when you're back, you have to rerun everything starting from the top, okay? Now, you have to execute it starting from the top, okay? You also have to verify that the code that you are running returns correct results. If the code does not return an error, does not mean that it returned correct results, right? So you have to pay attention to that. Now, you have to select correct runtime environment, right? Because if you don't select correct runtime environment, you're not gonna see the options that we're talking about, right? Like adding part session data frame, etc. Or if you select the older version of Python, the code that you get might not work. It may or may not work, okay? So please make sure that you select the correct environment when you run in the notebooks, okay? Well, this is a little bit of the Markdown syntax, and I spelled it out for you because for your assignment, there are two parts. First part, the code is given to you. Second part, you have to write the code, and you also need to put the Markdown, right? It's required. It's part of the requirement. You have to have the heading. You have to have a table of contents, right? Because when the notebook is long, I should be able to go to navigate to the section of it just by clicking on the link, right? So basically, this is just the syntax, like first level heading, second level heading is a 2 hash marks, right? And this is how you do the table of contents. Menu, what's a menu basically? It's a set of internal links, right? And each link is pointing to a certain part of the document. So you see this here? That's an anchor, right? It's anchor ID, Titanic data. And here the first element goes to Titanic data, right? What is that? That little hyphen, right? Followed by two spaces. It's just the bullet point, right? It's just the bullet, how you defined it. And all links must be enclosed in brackets. So this is just the syntax. What you could do, you're gonna have something similar, right? You're gonna have a similar table of contents, except you're gonna say allow Bohr's weight data, then you're gonna say load libraries, right? So you're gonna have select exploration. So basically what you're gonna have, the structure is about the same, right? You have to explore data, you have to parse the data, you have to split data into a training test set, run the module, right? So you're gonna have a similar table of contents in your notebook, right? And this is how you do the external links. So I spelled it out for you. But if you go to the notebook itself, right? Okay, if you go to the, now notice this here. I have the project open, right? I go to projects and I can find my project. There are changes to an interface, right? So this is the project that I'm looking at. And what I did was I uploaded the notebooks that I'm going to talk about today. And you're going to get a copy also. But first thing, I wanted to bring your attention to the change in the interface. Yes, there is a change in the interface. Like, look, this is overview. It looks totally different right now from what you saw before. See here, you have this assets, project assets listed on the left. What is asset? Remember, this is the data set notebook, right? Here you have resource usage. This is how many hours you spent inside this project. This is the time spent inside this project. Okay. Now here, assets. So now everything, there is no breakdown anymore between notebooks and data. You see it like this, but you can do over here, you can click on data. It will show you data only. If you click here, source code, it will show you notebooks. Okay. So I have this notebook here. This is a Titanic, right? I'm gonna open it up now. And this is what I was talking about. I was talking about the markdown here. So if I click on the edit, right? If I click on the edit, this is how you can see. Well, but remember, clicking on the edit button starts what? The kernel. Clicking on the edit button starts the kernel. And what does it mean right now? My hours are gonna be running, right? But I'm opening up the notebook because I wanted to show you what markdown I'm talking about here. Okay. But see, that's a slide and another slide. This is how to do the table, and I'll show you. Well, basically, this is an HTML code, and I'll show you how to get to it. 1 second. Go back. It's still loading. Right. Okay, there we go. Now it's finished uploading, right? There are changes to an interface, but what did not change is that the code does not change. This thing does not change, right? So not everything changed. Okay, look here. If I double click here, I can see the syntax. First level heading, see this? One hash mark. This is just a text, right? Nothing here, just plain text. This is a table of contents, right? Well, see this, this is a link in a bracket. This is a link. This is an anchor. It's an internal link. It tells where it's pointing to, right? Okay, now it looks like a row cell, but how do I return it back to Markdown? I have to run it, see, and then now it looks back, it looks again nice like links, right? Well, like for example, see this, I want to do load libraries, I click and it takes me to this cell, okay? That's the whole idea of table of contents. You don't have to scroll through the whole thing. Now let's take a look at this. Well, see this is a table. This is defined as a table. How many columns are in here? I see 4, right? 4 columns, right? And this column here, the image in this column spans through how many rows? 7 rows, right? So when you do the code, it looks like this. First of all, table, you have an opening tag and a closing table tag, right? That's a good to know thing. Now you have what? Table row, opening tag, and closing, right? So the first row, it has several cells, right? Table data, that's a cell. And the first cell here is blank, right? Then in here, in the second cell, I'm saying what? Variable, right? It's a first line description. And then in another cell, this is what? It's an image. This is a link to an external image. Now here I say row span because the cell spans through 7 rows. The cell height is the 7 rows, okay? And then in here, you're gonna have 1 cell less because that cell, it spans through the whole column, right? So that's it. This is basically, don't worry about the style. This is just, okay. And then when I run this cell, it's gonna return it back to the table of contents. Okay, so just know this. I was talking about the markdown in here. Okay, this is more advanced. Tables are more advanced. Now, another thing we need to talk about the parsing function for the data. Trust me, when you write those notebooks, most of the time, when you're getting an error is in parser function, which is this guy. Okay, so this is a Titanic data. Let's look at what this thing is doing. This function takes one row from the CSV file and it tries to parse that row, right? It tries to break it down into the set of values, right? So it takes one row at a time and it tries to split it. What's in the row? Look, what you do in here, you list the columns here, right? So the first column is a name, second column is what? ticket class, right? P class, age, sex, survived, and person ID, right? It might help to list like this because look, in Python, the numbering starts from 0, right? The first element in the list is at the index 0. So you label it. Then you're looking at the whole line. You're looking at one line, and what you need to generate in here, this is called the label document, right? You're generating the label document. The first element in the label document has to be identification. Here, it's a delimited list of predictors, right? The columns that you use are predictors, and this is what you're predicting, right? So how is it done? First of all, here it's looking at this label. Label is in which position? It's in position number what? 4, right? It's in position number 4. So we want to write it, you have to write it as 1.0 or 0.0, right? It has to be written like this with 1 decimal place. So what you're saying is that if the value is greater than 0, then it's 1.0, otherwise 0.0. So this is gonna be what? Your third parameter in here, right? This returns the label document with 3 parts here. Now, the first part, what is the first part? Is an ID, right? Person ID. It's in position number 5. This is what values of 5 mean. Next one here, this is a concatenation. What are you using to predict? Well, you're not going to use name. Why? Because it's a PII. It's a personal identifying information, which should not be used in analysis. So in a paper, you would probably write it down that we exclude name because it's a personal identifying information, right? Okay. Well, it's not unique identifier, but it's a PII, personal identifying information, such as social security, name, credit card number. We're not going to use this in analysis. Okay. But we will use person ID. Person ID is just a number. It uniquely identifies the person, but it's not like a name, or we cannot find a person just by having this. Okay. Now, this returns label document, but over here, if I go down, there is a place where I'm calling it, okay? Well, over here, I'm calling it. Well, see this? Basically, remember lambda, right? It's a function. So what it's doing is this here. It's gonna call the parser, but before it does this, it's gonna skip the row. If the row contains a string name, it's gonna skip that row. But the row is gonna contain name if it's a header. So we have to remove the column heading. That's how it's done. It's skipping the row if it contains name, right? Because name is the name one of the column. It's gonna skip this, okay? Now in here, it's gonna print the first 5 records. And if your first record shows the column headings, it means that somewhere you did not remove the header rows. You have to go back and see what you're doing in here, right? Okay, because when you edit this code for logistic for the low birth weight data, there is no column called name. It's something else, right? So suppose that you forgot to edit the code. And then when you print the first 5 records, you see the column headers. Why do you see them? Because you may have done something wrong. You need to go back and check the code, okay? So promise me that you're gonna check the code. Now, next thing is, so we talked about the parser, right? It creates a label document. Yes, and please take some time to list your columns and put the indexes, right? And take some time to think which column is a predictor, which position is it at, right? So here, just a little bit, yeah, and another thing is that do not delete the word label. So here, there is a label document definition. Do not delete the word label, because if you do that, you're gonna be getting an error, okay? Do not rename this. Next thing is, well, this is basically, you're using a pipeline for this, right? So you dividing data into training and test set. Well, before this course, you were told to do 70% and 30%. You're more than welcome to do that. But then Remember that pipeline, it consists of 3 stages, right? Tokenizer, hashing, and method call. So that's what basically this piece of code is doing, okay? And you're using label documents. Here you're specifying the input column, right? And input column, what do you call it? You call it person info, right? And output column, see if you've got these features, etc. So you're using a pipeline to call the logistic regression method, right? Okay. Now, some tips for part 2. You want to make sure that the columns in the data frame have correct data types, right? So what do you need to do? You have to remember that the code where you're reading the data, that you put this in for schema, okay? You have to put this in for schema. Next thing, you need to remember that most of the error happen in the parser function, okay? Now, you cannot just take this. This is what you cannot do. You cannot just take this parser function here, copy, paste to your code for part 2. You cannot do it because it's going to be incorrect. This code here was written for Titanic data. Number of columns is different. The index where the predictors and the index where the identifier is located, they're different, right? So because if you take it as is, without changes, you'll be predicting if a mother is a smoker. Trust me. The purpose of that part 2 is not to predict if the mother is a smoker, right? So if you take this code as is, you're going to be predicting the wrong column. And the analysis that you are presenting are incorrect because you're not doing what you were asked to do, right? So just keep that in mind. It's a very serious mistake. You have to edit the code, okay? Because this is for Titanic data. You're working with different data, okay? Now let's go back. You know this, right? You cannot do the plugin. That's not how that works in programming. You reuse the code, but you not do this. Now I prepared another example for you. An example is with Framingham data. You build logistic model to predict any 10-year risk of coronary heart disease, right? So basically, you have the patient information such as age, gender, and some health information, right? Such as the vitals, body mass index, and etc. And you want to predict if that person is at risk. All right, 10-year risk, you want to do that. So I'm going to show you that notebook. There are some advanced plots that I prepared for you. But before we do that, first of all, what you have to do, you have to stop the kernel, right? Shut down. Before I do that, I have to go over the changes to an interface. So I shut down. I shut down the kernel. I'm going to come back to here, right? Now I'm here. Well, there are some changes to an interface. Now, if you want to see if you have any environments running at the moment within this project, you click on Manage. And this is just the project. And when you click on environments here, it's going to show you if anything running inside this project. It does not because I stopped, right? I'm not using anything. I'm not running anything. But here it just shows you what you have used inside this project. And this is what you have used for this month, right? Well, so February, we had this session in February. I used this project in February. So I was careful. This is how much I used, right? And what did I do? We had a demo last time, and I had to run the notebooks that I prepared for you, right? I had to run it today to make sure, because this is a new Python version that we use now. It was written in an older version, and I just showed you stuff, right? We were just talking, so I used that. So now, well, I had to show you how to add new notebook. It's going to be a little bit different. To add data, it's still the same. You're going to click here and upload data, right? But right now, starting from today, to add new notebook, this is what you have to do. Watch. You're going to have to click on the Add to Project. Do you see the change in the interface? So if you see that, don't cry. Before you cry, watch this recording. Now, look. You can do multiple ways here, but if you scroll down, you're gonna see this is now under code editor. You have to click on Jupyter Notebook Editor. This is how you add notebooks from now on. Everything else here is the same. Everything else in here is the same, exactly the same, okay? The only change is that you click on a different, before, when you clicked on add to project, there was an option called notebook. Right now, there is no option such as notebook, but you have to go to the code editor. You have to add the code editor, okay? This is what now it's called, Jupyter Notebook Editor, okay? This is just change in the interface. I'm showing you the change. Now, here is the source code. See this? Over here, asset types. If I want to see only the notebooks, I have to select the source code. Notebook and the source code, those terms are used interchangeably right now. So this is the notebook that I prepared for you. And this shows that I edited it 3 hours ago. Okay, I'm going to open it up right now. Okay, I'm opening it up right now and I'll show you. This is a gift. It's another example. So for right now, I'm looking at it in the read mode because I want to save my hours, right? So here it is. This lists the columns that are in a table. I mean in the data. Sorry. So see here, I have variable description, and this is just the link to external image, right? So here it is. And I want to predict the 10-year risk of coronary heart disease. First step here, we're loading the libraries, right? So here, this is a parser function, but this hash thing is a comment. The reason I have this, I was trying to play around because this data set is bigger, has more columns, and I was trying to test different combinations of predictors. Yes, because when the data is large, right, you want to look at the relationships between the columns. You want to check if the predictors that you're trying to use are independent from each other. So just as a little gift, I'm giving you some more code in here, and I'll show you what I'm talking about. Well, first of all, right, I had to do this here to access the data, right? I had to do import Spark session data frame, and I must say this, infer schema equals true. Infer schema true, right? Because I want to read the data types correctly. I had to update the bucket name. So when you take this example, guys, if you run it, you have to update this part because this is going to be your bucket number, right? This is your credentials part. This is going to be run in your environment. And then there is another cell where you have to update the bucket name, okay? Now, well, here I'm previewing the data, right? This is data exploration. What print schema does, it's gonna tell you the column names, their data types, and if the data types can have missing values, nullable, right? Now, if you do not see, this is an integer. If you see is that all of these are characters, then you have to go back and you probably forgot to add this infer schema option line. It's important because if you don't add infer schema line, you're gonna see incorrect data type. Then when you try to take the average age, for example, it's gonna give you the average ASCII value of an age, okay? It's gonna be wrong. You're gonna be analyzing incorrect results. Now here, this is a number of patients, right? Total number of patients. But if I was going to run the query or something to calculate how many males and how many females I have, right? If a gender column is not missing any values, right? The number of males plus the number of females should be total number of patients. If you're doing the counts, and if the counts don't add up to the total number of rows, it means that you're doing something wrong. You have to go back. Okay, keep this in mind, please. Well, here, this is a little repeat, right? This does? It's showing this group by, right? So we are showing the count, how many people are at risk, how many are not, right? So just by here, do you see what's going on, the unbalanced data, right? You see that? Also, see this? So I have these two numbers. I have my counts. When I add them, the sum should be this. That's how I know that I'm doing it right. Okay, you have to check your work. The code ran, but it does not mean it returns the right result. Well, here, what you're doing is that you are doing more calculations, and then you're doing this is a plot, right? This is a plot. You're doing a bar chart plot, and you're showing this one that is by education. You're breaking down the counts by the education level. See this? So this is a bar plot by education level. Here, what you're doing is that you are calculating the average age of people who are at risk and of people who are not. See, that's what it's doing. But again, if you're seeing something odd, right? If an average age is perhaps 100, is this realistic? Then you need to go back. Maybe you're doing something wrong when you're reading the data, right? Well, here it's just showing the age distribution for all patients. And then here it's just showing age distribution for people at risk, right? So this is the distribution for people at risk, right? You can do that, the histograms. But what is this doing here? This is just returning a list of columns. This is how you check if the column has any missing values. You take in a sum, you check in is null, right? And take in a sum. So if you see 0 across the board, it means there are no missing values. But if, for example, education, if you saw number 5, that would mean you have 5 rows that are missing a value, right? But this is just for you to know, this is how you check in Python for missing values, okay? And this is more about the data frame information. Notice I'm using the pandas data frame class in here, okay? So this is still data exploration. And this is you're gonna like it, the describe thing. This available only for the pandas library. And do you see this? You got all of this count, mean, standard deviation, 25%, 50, 75, and the maximum. See this? You have this for the columns that are numeric, right? Everything is numeric here in this data, in this example. Now here, well, what we did is that you probably want to look at the columns distribution, right? You could write the code to show one chart at a time, but this is a gift. You have this little function in here that is going to take all columns in the data frame, and it's going to visualize all of them. See this? So here, this is where you're calling this draw histogram, and you are sending the data frame, right? And you send in the list of column names in the data frame. And this is how you want it to look like, number of rows and number of columns, right? So for your data, you're gonna change this because you're gonna have a different number of columns, right? You're probably gonna have a different figure size because you're gonna have a different number of columns. But what it does, it just, this one, it just plots the histogram, right? But it's calling this function on all of them, right? It's going to call all columns, and this is how it's doing. Now this one, you may remember from earlier course, there is a package called Seaborn, and you can use the pairwise plots, but you will have to wait a little bit. This takes a little bit of time to run, okay? Well, what I will do is I'm gonna give you this, and I'm gonna keep the output to save you some hours. Okay, you can look at the output basically, like I'm doing right now. Okay. Now, well, what this one is a heat map, but it also showing you the correlations between columns, right? Well, remember that correlation can be between what? -1 and 1, right? So here, lighter column means higher correlation in this case, right? So you may want to look at which columns are correlated, right? Because you want the predictors to be independent from each other. But for this data set, I can tell you right away, there is a, if person is a smoker and also number of cigarettes per day, probably I only care if a person is a smoker, right? So if number of cigarettes per day is 0, then probably none, right? So I'm probably gonna keep one of the columns, one of the other, but not both, right? So, and see here, if you have like scissors here, 0.7% correlation, then you have to look at this too, which one you want to keep, and etc. So I was playing around with combination of columns that I wanted to keep as part of the analysis, and I was looking at this little heat map here. See this? Like you can see this diastolic blood pressure and something else. Oh, the label is on the bottom. Systolic blood pressure. Well, usually if you have high diastolic blood pressure, you're probably gonna have high systolic blood pressure, right? So it's possible. But then you see that line one going across the diagonal. Well, that's because it's a column with itself. See this right? This intersection, it's a column with itself. That's why it's a 1. Okay. So you're not explicitly asked to do the correlation, but if you are aiming for a higher grade, you might want to. Okay. Now here, well, this is just the parsing data. It's calling it's calling. Oh, this is just over here. This is a parser function. This is calling the parser function. What am I doing? Well, patient ID is the name of the first column. How do I know it? Look here, I'm reading the data, and here I'm outputting the first 5 rows. The first row contains what? Column names, right? And what is this? This is a bucket name. This is a bucket name, remember? Now here, I'm outputting first 5 rows. My first row is a column names. See this? So you have to remove them. And how do you remove them? Well, when you run the parser, you skip the rows that contains per patient ID, which is a column, right? And in here, you're outputting first 5 records. So if in the first row, if you see the column names, it means that you're not removing the column headers. You're making your column headers to be treated as a data row, which is wrong. You're not gonna get the right results, okay? Here you're splitting the data into a training and a test set. And in here, I'm using 0.7 and 0.3, right? And here, well, this is actually the wrong thing to do for a large data set. Well, but it's actually printing the first 20 records. We're good. We are good. But it's not good to do here. I'm attempting to print all of them, but thankfully it only does the first 20 rows. Okay, you're just gonna output the first 20 rows. Here it's built in the model, right? There is no output. Do you remember there are 2 types of commands in a Python, right? So some commands, they're not returning the output, right? But then you're gonna have output here. What is it doing? It's taking, we built the model, we are training data, now we are predicting for the, what was the test data, right? So this is a probability that the patient is at risk, right? Something like that. Skip. And in here, you just print in the metrics. You want to look at the first, it's just a breakdown, right? Actual counts, and then the predicted counts, and then you're just doing the comparison. And you're doing the model evaluation. You have to look at these metrics, remember that. And you also have to do in the reading, please read about area under the rock curve, because you want to discuss it in your results interpretation. And also the F measure, right? And then also the rock curve plot. What does the area tell you, and etc. This is required. You have to discuss this. Okay. Now let's come back to our slides. So this is basically, I'm just doing an explanation here. What I'm showing you And I gave you the correlations code, right? And those are the packages that you have to use. Remember the Seaborn package, Seaborn, and it's using the pandas data frame. So you have to convert it to pandas, right? That's a correlation map. Okay. And this is something that everybody forgets how to do. Well, most of the people forget how to do. When you're done with your notebook, right? I have to go to edit mode to show you. Well, first of all, what you need to submit. You have to submit how many files? Who cannot count until 3? So 3 files, right? 2 files. The first file is the output of Titanic notebook. Second one is the output of logistic of the low birth weight notebook. And the third one is the paper, right? So what you need to do is this, look, file, and then there is an option to download this, right? And you're going to download this HTML. This will be saved somewhere on your PC where your default downloads go, right? Then you can open a file, it will open in a browser, and you can also save it as PDF. Usually, if you do this Control P or print, something like that, you will see an option to save it as Microsoft PDF, okay? It's better to submit the PDF. It's better to submit because sometimes when you submit the HTML, you may lose the charts, okay? You may lose the chart sometimes. So just remember that. You remember it now. And what else is in there? Oh, this is just another example, okay? Another example of the notebook. And also, okay, so I'm gonna close this. I'm here, right? So most of you probably still remember that if you selected the wrong kernel, you would have to change it here, right? This is where you would change the kernel if you selected wrong environment. And it will ask you if you want to stop the current kernel, you want to stop it, right? But please do yourself a favor, follow instructions, right? Another thing is this, when you change something in the code, well, you would need to do kernel, this one, restart and clear output. I'm not gonna do it, I don't want to clear output here because I want to export, I want to save this file after this session and I want to give you a copy of this notebook, right? And the data so that you have extra example to look at, okay? Now, another thing is that we have 3 people who ran out of hours. Yes, 3 people were not careful. I'm not going to name it, it's confidential, but what I was trying to say is that you have to watch your hours. And if you run out of hours, what you will do is that you will submit the Salesforce case, and what to do next is depends on where you are in the assignment. So submit the Salesforce case, and also tell me this, are you done with part 1? Right? Are you done with part 2? Have you started part 2? Because, well, it all depends. Maybe you did everything in part 2, but all you had left was you just missing the headings, right? Something like that. Then if you have an output with missing headings, maybe it's gonna cost you a couple points, right? Is it gonna be worth doing what I'm gonna tell you to do if it's just a couple points? You know what I'm saying? Because yes, if you run out of hours, the only option that you will have is, but don't do it until I tell you to do, you would have to create the 29 days trial account and use that to do the whatever is left. Yeah, because there is no way to add the hours until next month. If you run out of hours, no hours will be added until next month. But they have a workaround, but it's better not to do that because you'll be redoing the work from scratch. Okay? So please, please, please do yourself a favor. So speaking of that, what am I gonna do now? I'm gonna stop my kernel because I don't want to use my hours, right? And then when you're done, you still want to make sure this administration, and if you go to environmental runtimes, this is across the board. I should not see anything that is running at the moment. Nothing should be running at the moment. And take a look at this. I had to prepare for the session, right? Look at how much capacity hours I've used. Just 2 hours. See this? Because I was very what? Careful. I was careful. Well, of course, you're gonna use more than 2 hours, but you're not gonna be programming for 30 hours, perhaps, right? Because look at this, 2 hours is a little bit more than an hour, clock hour, right? If you're careful, right? If you know when you're not running the code, you're stopping the kernel, this is more than enough. You can do twice of this assignment, trust me. Oh, and another thing for those of you who want to aim for a better grade in course content, there is a notebook for Titanic data that implements the naive Bayes method. So you're asked to discuss alternative methods. If you want to aim for a little bit higher grade, no guarantee, but if you want to, you could try, and if you have hours left, you could try running the naive Bayes method just to see and compare the results, okay? Does it make sense? Now your turn, guys, questions. I want to see questions. Questions. Everyone, questions, please. I know it's Friday, I know you're tired, but you still have this assignment. Please, questions. All, any questions? There are no questions? Then I have a question. How many of you have started working on this assignment? Because at this point, you should be working on part 2. People, you should be working on part 2 at this point.
This is Alex, Alexander
Yes.
Harris. I started and I just now found the way to do the table of contents. So you answered my question already with the table of contents.
Oh.
And then my other question was just about, how we do more graphs, which again, you guys showed with the C, was it C graphs? Siemens?
Seaborn, yeah, Seaborn.
Yeah, that's awesome. So
yes.
both of those answered my questions. So
Oh, well, it's because I have been doing this class long enough to, well, there have been questions last semester too, so I kind of like look through and I put it in example, trying to, well, not read the mind, but it's based on the past semesters, etc. Yeah, and I'm gonna give you this example. Well, the reason it's given at the session is because when you first look at the walkthrough, right? When you first look at it, it's too much to throw this in, so it's introduced in pieces. And also because you're not explicitly asked to do the correlation plot, but if you want to aim for a higher grade, you probably want to look at the correlations, right? Remember in your prior coursework, logistic regression or naive Bayes method, you were looking at the correlation. So go ahead and apply it here. This will be very good, right? So apply what you learned in the past courses here. That will help your grade. Well, I don't know, but if I were you, if I was taking this assignment, if I was doing it, this is the project I would take. Okay, so I'm telling you what would I do if I was trying to get an A in a class, if I was taking this class. Okay. Or if you are a student who consistently gets maybe like in the upper 80s, so this assignment you could, if you're done, right, with what you usually do, you have an opportunity to try to go a little bit above your normal, just to go a little bit above your comfort zone and try naive Bayes method. Try to do a little bit more so that see if you can hit the 90-degree mark this time. You see what I'm saying? Just try, just do what you normally do first, save the copy, but then if you have time left, try to aim for a higher grade. Even if you're a B student, do the B work as you usually do, and then if you have time left, if you have capacity hours left, try more, okay? And another thing is that we're gonna be, for the next assignment, part of it will be using capacity hours, part of it is not. So if you've used all of your capacity hours when you submit this assignment, please do not think that you can do nothing. No. Next assignment will have 2 parts. The first part, the part that involves the database, does not involve capacity hours. So if you run out of hours on this assignment, don't worry, because the first part of the sentiment analysis tutorial assignment does not consume hours. The second part does, but you can start with the DB2 part, right? So you will be able to still work on the next assignment, even though the hours will be reset on, well, this month you have 28 days, right? Yes. So, okay. So don't worry, because next month you're gonna have hours again. And the first part of sentiment analysis tutorial assignment, first part does not consume hours. RStudio that you'll use does, but not the GB2, okay? So you'll be okay, but you have to really stop the kernel. Trust me, with this you can do a lot of work if you know how to use it, all right? Because see, I'm using it too. Sometimes when I need to help you, sometimes I have to use it too, right? If you tell me something is down, I have to check to make sure it is down, you know, things like that. So, yeah. Any more questions? Questions? Yeah, but see, this assignment, you see an opportunity where you can go a little bit beyond your comfort zone, right? Okay. More questions? People? Professor Gorchova, do you have anything to add to the conversation?
Oh, I'm mute. No, I think they just need to start working, and if they have questions, they will be asking. But I think it's too much information already to digest. Until you start touching stuff, they are not coming more questions. So I think we should just end the session and let them work.
Okay, so what I'm gonna do is I'm gonna stop the recording, right? Okay, no problem. Okay, stop the recording.
And the most important, don't hesitate
Yeah.
to ask
Mhm.
questions.
Yes.
That is part of the learning.
True. Okay, so I'm gonna stop the recording.